Hello, this is KCLabs coming at you. This is a standard window motor setup. It has about a 6-inch or so radius on the armature there, and as you can see, it's running. It's got the bipolar sequential circuit set up here, the Bedini standard bipolar circuit, and it also has 2 batteries in the bottom here. And I've got those running at, so the whole circuit runs at approximately 24 volts on average. Now, I've been playing around with it, so the voltage dropping down a little bit, and apparently there's something going on when you first start up this thing. Anytime you get a resonance, you're going to have a loss in voltage if it's not at resonance. One of the things that I've been dealing with this is that I managed to get the number of winds of wire just right so that the voltage across the batteries wouldn't drop down. And this was kind of remarkable to me. This was, and I think it's, I've had it happen twice now, the first overunity device that I've ever created, actually, and it works fairly good. I really like these window motor setups because the window motor setups, you can actually tell how much power is going into the battery by the voltage on the battery. Whereas with the schoolgirl setups, you've got the other batteries and you sometimes don't know exactly how much power you got going in there. You've got a situation here where your voltage on your battery tells you exactly whether or not you're putting more power into the device from the device or not. Now, a lot of people think this is kind of strange, but it's not so difficult at all. I'm going to go ahead and stop this for a second. As you can see, the rotor, the design of the rotor here, I'm going to go in a little bit closer. I've got a metal, it's on a metal file box, and that's why it's kind of circulating at one spot, and you're going to have a set of nodes kind of it's going to stop in a certain spot here. Doesn't cause too much of a problem, but of course we know that anytime you have a magnetic field going through something like steel, it generates electric current, which causes an IR loss. So anyway, I'm actually think I'm doing pretty good. Now keep in mind, I had to adjust the number of winds on this thing. Apparently, if you get too many winds, the speed of the rotor will actually drop off. If you get too few winds, you end up with a situation where it's not in resonance. And so those of you planning on creating something like this, just keep in mind that the resonant properties of this thing are really important. Let me show you. Let's see here. We go up to your basic Tesla circuit here on the top, and as you can see from the left, you've got a primary. It goes into a secondary where it's resonant at A, and then you've got at B where you've got your you've got your spot where it makes a spark, your spark gap, and then it goes into the primary of your high frequency, high voltage type of a setup here. Now, the thing about it is, whenever you set up a setup like this, and at the Tesla coil deal, you'll end up at a very high frequency that starts to develop. And it starts to develop because you are putting in a resonant frequency. When you put in a resonant frequency at A, across that transformer, this resonant circuit starts to develop a high voltage because the impedance of this parallel resonant circuit goes way up. And consequently, as the impedance goes way up, the voltage goes up to the voltage applied. But in this particular circuit, there's also another, you've got to multiply the whole thing by Q too. The Q of the circuit makes a difference in how much voltage you actually get out of that particular parallel resonant circuit. And as you can see in the spark gap, when the voltage gets up to a certain point, it actually crosses over, causes the wonderful, nice little sparks that everybody gets on their Tesla coil. Now that having been said, we go down to the bottom where I've got a schoolgirl circuit. This is a standard Bedini circuit, but if you'll notice, the battery in that particular, I've got two batteries there. One is the supply battery, and the other one is the charging battery. The charging battery is essentially the same as a capacitor. And when you realize that this particular battery is actually a capacitor, then you can see that the whole thing is acting like a parallel resonant circuit. And what you have to do is you have to get the whole thing into resonance in order for the voltage at C to rise above what you're actually applying. Now, we have record, and there's a whole bunch of people that have done work on these things, and they've gotten voltages of upwards of 800 volts, 300 volts, 1,000 volts, somewhere at C in some of these schoolgirl circuits. So what I want you to realize here from this particular video is that the idea is you can measure the voltage at C to figure out what the efficiency factor for your parallel resonant circuit is, and from that efficiency factor you can actually figure out how much power you're getting out. You can figure out what the efficiency of your coil is, the whole ball of wax, just by measuring the voltage at C. So the idea is if you get a higher voltage than what you're putting on there, you've got a Q that's greater than 1, and anytime you've got a Q that's greater than 1 in a parallel resonance circuit, you have a situation where you are generating extra power. So, in this particular circuit, and I'll get it going here, as you can see, it starts up slow. The bipolar circuit kicks in. You have all these things going on, but it actually acts in resonance with the batteries that I've got supplying it. Those of you who are interested, I don't believe you can get to overunity any other way. A parallel resonance circuit we're dealing with here is actually pretty interesting. I've had this ring running, except for this particular movie, for about a day and a half, 2 days. It's sitting at 20.5 volts, and this is the second time I've had it sit at a voltage like this for a long period of time. It just seems like it wants to keep on going. So, with that having been said, you got the general notes from the bipolar sequential circuit on the internet. You can get yourself some batteries. I'm using 12 volts. One of the things about the batteries is that if you raise the voltage on the battery, the voltage times the number of amp hours is the number of watt hours. So you can actually figure out how much energy you're putting back into your system by measuring the voltage across the batteries. So as you can see, it's starting to speed up. As far as the coil goes, I picked a flat coil because according to the definition of L, or the inductance, a flat coil is actually a higher inductance coil than a long cylindrical coil. And so that's the reason why I selected a flat coil. I'm debating on that at this point. Newman and Bedini and some other guys use the circular coil, long coils, but I just don't know if I'm trying to evaluate that right now. At any rate, KCLabs over and out. Thank you very much.